Okay, so this is the first part, the first time we're going to try this flip. And this is the first section of chapter 9, and this is 9.1. This is graphing quadratic functions. Notice you will need some graph paper for this lesson because we are, in fact, graphing quadratic functions. And just as a reminder, as you're going through this video and as you come across any questions that you may have, you want to write them in the margin of your paper, and we'll start with those questions tomorrow in class. Okay? And I want you to copy down these key concepts, pause me as you copy it, and replay me when you finish. Okay, the first term we're going to talk about is a quadratic function. What is a quadratic function? Well, a quadratic function is in the form of, that's not a negative, that's one of my bullets. Y equals ax squared plus bx plus c, where a cannot be 0. And that's all that's saying is we just need something to be x squared, okay? And a can't be 0 because if a was 0, then we would cancel out our x squared. So we don't want that. That wouldn't be good. And this is known as our standard form. Okay, and then we've got parabola, and that is the graph of a quadratic function. So you'll hear me call the graph of the quadratic function a parabola, and it looks something like this, or it could also look like this. This is what a parabola is, and this is the graph of a quadratic function. Okay, and then we've got both things. We've got minimum and maximum. This is the lowest point of a graph is a minimum. A maximum is the highest point of a graph. And over here on my kind of little makeshift parabolas over here, this is what's considered a minimum, which is the lowest point of a graph. Maximum would be on this little tiny graph over here, and that would be the highest point of the graph. All right, and then we've got vertex, which is the point of the parabola, which is either the maximum or the minimum. And that's, you know, these points right here, this is called the vertex. And then we've got finally symmetry, which is half of the figure matches the other half exactly. And then our lastly, axis of symmetry. And this is the line that divides the parabola into two equal halves. And that's, whoop, my line's not very straight there, but basically we're just splitting the parabola in half here, and that is what the axis of symmetry is. And how we find that is we use this formula right here. X equals negative b over 2a. Now this is important. You'll want to remember this. The axis of symmetry is x equals negative b over 2a. Okay, here's one more thing to copy down. Pause me as you copy this, and we'll go over it as soon as you finish. So replay me when you're done. Okay, now these are more about maximum and minimum values, which I just touched on a little bit before. The graph of f of x equals ax squared plus bx plus c, where a can't be 0. If that graph opens upward, it has a minimum value, and that's when a is greater than 0. So when this value right in front of x squared is positive, you're going to have a minimum value, and it's going to open upward. Okay, well, what happens if it's a negative? When a is less than 0, it opens down and has a maximum value. Okay, and it looks similar to this right here. When a is positive, you're going to have a minimum value, right? The graph opens upward. When a is negative, like you see in this example, the graph is open downwards, and we've got a maximum value. Now, it also talks about the range of a quadratic function is all real numbers greater than or equal to the minimum, or all real numbers less than or equal to the maximum. What does that mean? Okay, well, we've got this minimum point here. Let's say that's at 3. Okay, so my range is going to be all numbers greater than 3 or equal to 3. Now, similarly here to the maximum, let's say that's a value of 1. Okay, and this is going to be all values less than or equal to 1, right? Because there's no graph up here above it, so it's going to be everything less than that point at your maximum. Okay, here's our first example. And this is how to graph a quadratic function. Okay, so first of all, you're going to create a table of values in order to graph the function. And then after we graph it, we're going to state our domain and range. Okay, so here we got y equals x squared minus 3. And how we do that is you just pick some values, -2, -1, 0, 1, 2, excuse me, and we're going to plug in each value for x to find our y. Okay, so here's our function here. We've got y equals x squared minus 3. Now we're going to take this negative 2 and plug it into x squared. So we've got y equals negative 2 squared minus 3. Negative 2 squared is 4 minus 3, and y equals 1. Okay, and then we're going to do that for each one. We've got, let's see, y equals negative 1 squared minus 3. 1 minus 3 is negative 2. And then we go to our 0. We plug in 0. Y equals 0 squared minus 3. 0 minus 3 is negative 3. And then you're going to have a lot of scratch work, obviously, here. Y equals 1 squared minus 3. 1 minus 3 is negative 2. And y equals 2 squared minus 3. 4 minus 3 is 1. Okay. All right, and then we're going to take these points here and we're going to graph them on our graph. Okay, this is where your graph paper comes in handy. So we're going to plug in negative 2, 1, negative 1, negative 2, 0, negative 3, 1, negative 2, and 2, 1. Okay, and now I want you to draw a nice smooth line connecting all your points here. And now, what would you say this is? Is this a minimum or a maximum? Well, this is a minimum, right, because I have a minimum point. And notice my value in front of x squared is positive, okay? Kind of see that little pattern going on? And now it asks us to state the domain and range. And our domain is, on those little squiggly lines, you know that I love those, all real numbers. Okay, and how I got domain is this graph is actually going to extend on and 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 on in both directions. And so we're actually, remember domain is all x values. So we're going to actually include all of these x values as we're going, you know, on and on in both directions. That's going to include all x's. But our range is where it's a little different because it only includes from this point here at negative 3 and above. Okay, so our range is all values such that y and y is greater than or equal to negative 3. Okay? And that's because this is our minimum point, and it's all values from negative 3 and above. So y is greater than or equal to negative 3. Okay, now this is your turn. I want you to pause my video. I want you to try this example as best you can and go all the way through it and then replay me when you're ready for the answer. Okay, so now you were supposed to take this negative 2 and plug it in for every x in here. And I'll do the first one for you and then I'll just fill in the chart. So we've got y equals 2. We've got negative 2 squared minus 4 times negative 2 minus 5. And we get y equals 2 times 4 minus negative 2 times, negative 4 times negative 2 is positive 8 minus 5. 8 plus 8 minus 5, 16 minus 5, and y equals 11. Okay, and you do that for each one of these, and you should have gotten 1, negative 5, negative 7, negative 5, 1, and 11. Okay, now from here, we're going to come over to our graph, and we're going to plug in, or we're going to graph or plot our points. So we've got negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Negative 1, 1. 0, negative 5, 1, 2, 3, 4, 5. And 1, negative 7, 1, 2, 3, 4, 5, 6, 7. 2, negative 5. 3, 1. And 4, 11. Okay, and yours should be a little bit smoother than mine because I'm on a smartboard. It's kind of hard. Okay, so your parabola should look something similar to this. Your domain is all real numbers, and your range starts at this minimum point here, all numbers y, such that y is greater than or equal to -7. All right, now this example is a little bit different. We've got, we want to find the axis of symmetry. We also want to find the coordinates of the vertex, and we want to find if it's a maximum or a minimum, and then we're going to graph it. Okay, so first of all, we want to find our axis of symmetry. Axis of symmetry. And if you can remember from what our axis of symmetry is, we had that formula that I told you was really important, and that was x equals -b over 2a. Okay, now remember we have our standard form of ax squared plus bx plus c. Okay, now these all stand for the coefficients. Okay, so when it says -b here, it's going to talk about this term right here. So we've got x equals -b, which is 4, over 2 times a, which is this term right here, which is kind of a understood 1. So this is x equals 4 over 2, which is -2. Okay, so our axis of symmetry is -2. All right, then it asks us to find the vertex. Okay, well, how would I find the vertex? Okay, well, we're going to take this axis of symmetry and we're going to plug it into the original equation and we're going to find our y value. Okay, now we've got our x value, so we're going to plug in y equals -2 squared plus 4 times -2 plus 3. And that's y equals 4 plus -8 plus 3. Y equals -4 plus 3. Y equals -1. Now it asks for the coordinates of the vertex. So the coordinate is actually going to be this -2, -1. Okay, so this is the vertex. Okay, now is this a maximum or a minimum value? Okay, well, we talked about before what a maximum and minimum value was, and that was determined by this value here. If it was greater than 1 or less than 1, determined if it was a maximum or minimum. Woo, my tongue's getting tied. Okay, so we've got, because a is greater than 1, this is a minimum. All right, and then it asks you to graph the function. Well, how did we graph the function before? We had a table. Okay, well, we know that one of our points is going to be this vertex. Okay, so that vertex is going to be that middle point. So I want digits on either side of that middle point in order to graph my parabola. So I'm going to have -5, -4, -3, -2, -1, 0, 1. And notice this -2 is right smack dab in the middle. Okay, and so I already know this point as -1, or -2, -1. This is x, this is y. And I've got to plug in and find these other points here. Okay, so how would I do that? Well, I plug into my formula as y equals -5 squared plus 4 times -5 plus 3. -5 squared is 25 minus 20 plus 3. And 25 minus 20 is 5 plus 3, and that's 8. So 8 goes here. And we're going to plug those in for every single x value. We're going to get our y value. And when we do that, we get this as 3, 0, -1, we already know, 0, 3, 8. Okay, once we get all those values, we're going to come over to our graph and we're going to plot them. So we have -5 is 1, 2, 3, 4, 5. And we have 8. 1, 2, 3, 4, 5, 6, 7, 8. -4. 1, 2, 3, 4. +3. 1, 2, 3. -3. 0. -2. -1. -1. 0. 0, 3. And 1, 8. And we're going to smoothly connect these dots. Okay, and now a good way to check to make sure that we did everything right is to go back and see if our axis of symmetry is right, which we said was at -2. And let's see if our axis of symmetry is correct. So does this x equal -2 go straight down the middle? Yes. And what about our vertex? Is this at the vertex -2, -1? Yes. And because a is greater than 1, we do have a minimum. And do we have a minimum? Yes. So this is a correct graph. Okay, now this is a your turn one. I'd like you to do exactly what we just did on this last example, finding the axis of symmetry, the vertex, and graph it and tell me if it's a minimum or maximum. And when you're ready for the answer, play me and I'll give you the answer. Okay, so we have the axis of symmetry as x equals -b over 2a, and we plug in -6 over 2 times -3, and we get x equals -6 over -6, and x equals 1, +1. Our vertex. And remember, we find our vertex by plugging in our axis of symmetry into our problem. And we say y equals -3 times 1 squared plus 6 times 1 minus 1. And we get y equal to -3 plus 6 minus 1. Y equals 3 minus 1. And y equals 2. So my vertex point is at 1, 2. Okay, now, is this a minimum or a maximum? Well, because A is less than 1, we have a maximum. Okay, did everybody see that? All right, now we're going to take our table of values, and we all automatically know that we've got the vertex point of 1, 2, so we're going to put that in the middle. 1, 2. And we get values of -1, 0, 1, 2, 3. And here's x, here's y. And when you plug that in, you get -10, -1, 2, -1, and -10. So when we come over here to graph it, we have -1, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, kind of way up here. Kind of have too small of a graph here. 0, -1. Oh gosh, excuse my error. Blonde moment. Okay, so let's try this again. -1, wrong way, down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Oh gosh. No. What's happening? No, what's happening? Stop it. We're wigging out here. Sorry. I'm in fast motion. Look at me go. Okay, well, hopefully. Okay, it was just a minor little error. Okay, let's try this again. -1 to 10, and we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, -1, and we're at 1, 2, and we're at 2, -1, and 3, negative 10 down here. And you make a smooth little circle here, parabola. And we're going to check to make sure that our axis of symmetry is right. And we said our axis of symmetry was at x equals 1, right down here. And then we also have our vertex at being 1, 2, and that's right. And then we also have that this is a maximum point, and this is a maximum. Okay, so hopefully you got that one correct. Excuse that little technical issue right there in the middle. Now this is the last slide, and this is practice. Now I want you to try these problems and do the best you can, knowing what you know now. And I want you to come to class tomorrow prepared to show these in class, and we'll go over them tomorrow. So don't forget to add in any questions that you have so we can go over those. And happy practicing. I hope everyone does well.